Let's get started with the meeting. Arnold, over to you with the sky this month.
Well, thank you, Paul, and hi, everyone. For the sky this month, I'll be covering the period from tonight until November the 10th. And with Mars reaching opposition last night, I thought it would be interesting to take a look at some Mars space missions. And as for observing, we'll take a solar system tour and a look at some Halloween targets. Now, other than Earth, Mars is by far the planet we Earthlings have studied the most. To date, we have launched 62 missions to Mars, with about half, or 53% of them, either successful, still operating, or on their way. And here's a quick review of some of the Mars missions still operating. First is the Mars Odyssey orbiter that began sending back thermal and spectrographic images since it entered into Martian orbit 21 years ago this month. It's still active, and Odyssey has enough fuel for another 5 years. Mars Express performs high-level resolution imaging and mineralogical mapping of the surface, and also radar sounding of the subsurface structure down to the permafrost, and precise determination of the atmospheric circulation and composition. It has enough fuel to operate till 2026. And for the last 14 years, MRO has been sending back data on the geology and climate of Mars and searching for future landing sites and relaying data from surface missions back to Earth. And NASA intends to continue this one through the late 2020s. And the successful Curiosity rover has a laser for zapping rocks for spectrographic analysis. It has a drill for extracting rock powder for analysis through onboard labs, and it's investigating the Martian climate and geology for helping us assess whether the site inside Gale Crater ever offered conditions favorable for microbial life. And the rover's 2-year mission has been extended indefinitely. Its plutonium power supply can probably last for another dozen years. India's Mars Orbiter mission, or MOM, is a demonstration project to develop the technologies for designing, planning, managing, and operating an interplanetary mission. And MOM carries 5 scientific instruments for studying the morphology, topography, and mineralogy of the Mars surface, and the constituency and dynamics of its atmosphere. And it's got 13 kilograms of fuel left after reaching Mars orbit. It had 40, so it's still using it, and it's got a little bit left, so it may run for a few more years. Now, MAVEN was developed by NASA to investigate the upper atmosphere and ionosphere of Mars and how the solar wind strips compounds from this atmosphere. And this research gives insight into how the planet's climate has changed over time. And it has enough fuel to last until 2030, maybe longer. And a key goal of TGO is to gain a better understanding of methane and other trace gases that could be signs of microbial life or other biological activity. And a lander called Schiaparelli was deployed from TGO 3 days before entering Mars orbit, but it crash landed at over 500 kilometers an hour. And like other orbiters, TGO will also operate as a communications link for Mars rovers and landers. And it has a 7-year planned mission. And InSight is a robotic lander designed to study the deep interior of Mars. Most of its scientific instruments were built by European agencies. InSight is studying the size, thickness, density, and overall structure of Mars's core, mantle, and crust, as well as the rate at which heat escapes from the planet's interior. It has a seismic sensor that can interpret stratification of the interior through any Mars quakes, including meteor strikes or air bursts. Its initial mission is 24 months long, and it has another month to go. It's powered by 2 circular solar arrays, so potentially it could be extended. And here's what's en route to Mars. HOPE is an orbiter from the United Arab Emirates, their first interplanetary mission with a lot of international support. And the name HOPE is not an acronym. It's chosen as a wish for the future of the region, as it transitions from a petroleum-based economy to one focused on technology and information. The orbiter was constructed at the University of Colorado, Boulder, with UAE scientists and engineers working with the university's laboratory, for atmospheric and space physics. The University of Arizona and University of California, Berkeley also helped. A Ukrainian transport plane ferried the completed spacecraft from Colorado to Dubai for testing and then to Japan for launch atop a Mitsubishi Heavy Industries rocket. And scientifically, the probe will study the lower atmosphere of Mars to fill in gaps from the MAVEN mission and help paint a complete picture of Mars's atmosphere's escape into space. And China is sending an orbiter and rover combined in their Tianwen-1 mission. Between them, they intend to look for evidence of current or past life, produce Martian surface maps, characterize the Martian soil composition and water ice distribution, as well as examine the Martian atmosphere and ionosphere. And it also deployed a third component, a selfie camera, to take a picture of itself while in transit. Here's that picture. It had a lot of international support. Argentina helped track the spacecraft, and France helped with the rover's laser spectroscopy system. Australia contributed to the orbiter's magnetic mapping system and helped calibrate the instruments. NASA's Perseverance rover carries 7 scientific instruments to study the Martian surface at Jezero Crater. It will analyze surface materials, use ground-penetrating radar, measure wind speed, direction, pressure, temperature, test their ability to extract oxygen from CO2 for rocket fuel or life support, and detect organic compounds with fine-scale imaging and ultraviolet lasers. It will also cache samples for a future mission to pick them up and return to Earth. And its plutonium power supply will last probably 14 years. And the Ingenuity helicopter seen on the right, that's a demonstration project to see if a small helicopter can help a rover by scouting for suitable targets and choosing a path for navigating to them. It carries a downward-facing camera and is expected to fly 90 seconds before needing to settle down for a recharge. As for future Mars missions, back in 2016, Elon Musk said that SpaceX would attempt a cargo to Mars demo in 2022 and a cargo and crew mission to Mars 2 years after that. The vehicle for getting there would be Starship, currently under development at a SpaceX facility in Boca Chica, Texas. Development of Starship is progressing in fits and starts, so it really remains to be seen if SpaceX can actually send a Starship to Mars in just 2 years. The first prototype of the spaceship is seen on the left, and on the right is an image of what a future colony on Mars might look like. Now, with the spacecraft stacked on top of the booster stage, it'll stand 120 meters tall, which will make it the largest rocket to date, and construction has begun on the first booster stage. And it will have a payload volume bigger than the James Webb Telescope, and will also be designed for in-flight refueling from another Starship refueling vessel, so that you can go on interplanetary flights. And in the passenger configuration, Starship can carry 100 passengers, a crew of 100. In the cargo configuration, it can lift 150 metric tons into low Earth orbit, and that's 10 metric tons more than the strongest spaceship can do now. And because the entire booster stage and Starship spacecraft itself, they're both totally recyclable, that will reduce the cost of a launch to $2 million, just $2 million. Compare that to $450 million to launch a shuttle 10 years ago. And that facility in Texas will ultimately churn out a complete new Starship every 72 hours. That's the plan. And they also expect to have an operational fleet of 1,000 Starships. Are you interested in maybe sending cargo to Mars? In that case, you're going to want to download the Starship User Guide. Now, this morning, 2 Russian cosmonauts and an astronaut took off for the ISS and arrived there only 3 hours later on a very quick trip up to the ISS. And at the end of this month, there will be 4 more going up in the SpaceX Dragon. That's at the end of October. And this will mark the beginning of 7-member expeditions at the ISS. And now we're on to observing. For us in southern Ontario, the sky is as dark as it can be for about 9 3/4 hours tonight and nearly 10 hours by this time next month, or 11 hours. Visual astronomers, you can enjoy an extra hour of observing by including astronomical twilight and dawn when it's definitely dark enough to enjoy the solar system targets, for example. Daylight savings, that time ends at 2 a.m. Sunday, November 1, and here are the times of sunset for us in southern Ontario on November 1 and 2. And you may have heard there is a bill before the Ontario legislature to do away with these time shifts and simply use daylight savings as the one time we will use all year round, provided Quebec and New York State follow suit. Who knows, it might not be too far from now when we don't do clock changes anymore. Now, auroras. Years of research show that there is an increase in aurora activity when the Earth's magnetic poles lie perpendicular to the solar wind at the equinoxes, producing what's called equinox cracks, which the solar wind can pour through for hours and excite the upper atmosphere. The cracks are the result of south-facing or south-moving solar wind elements brushing up against the northward traveling Earth's magnetic field. And where they touch, they cancel each other out, opening a hole that the radiation can pour through. A study of auroras in the past 57 years show that September and October are two of the most active months of the year for solar geomagnetic storms and auroras. And if you would like to get an alert about auroras that may be happening now that we are in that active period, and now that solar cycle 25 is ramping up, you can go to the website shown on this slide and sign up for the alerts. As I've done here, I've signed up for advisories, and as a result, I get an email once a week, such as the one on the right, and it will let me know if there's any solar activity, geomagnetic activity that may produce auroras. Another solar effect is a zodiacal light, which is easily seen in the fall in the east before sunrise when the ecliptic is quite vertical. And I've got a image here lifted from Stellarium, and I'm not sure how well it can show the zodiacal light. So there's an image in the upper left corner taken in 2012 of exactly this scenario when Venus happened to be in the same position as it is now. Now on to the moon. We're in the dark stretch of October right now with the new moon just a couple of days away. It will actually be a super new moon occurring at perigee, and that should create some interesting tides. And next week, the moon sets just after midnight, Tuesday night into Wednesday, so it will not interfere with the Orionids peaking that night. At nightfall on the 22nd, the moon makes a tight triangle with Jupiter and Saturn and comes close to Mars the following Thursday. The falling leaves moon, or the hunter's moon, is on Halloween night, Saturday, October the 31st. It's just after apogee and will be the smallest micromoon of the year. And it's also the second full moon in October. Some people refer to that as the blue moon, the second full moon in a month. The older definition is the third full moon in a season with 4. If you follow that definition, it won't be until November's full moon. But that's just a name. It doesn't really matter. And dark skies will return to us in the second week of November. Now, when the moon is one day past first quarter, there's an opportunity to see Rupus Recta, commonly called the Straight Wall. It's a linear fault on the eastern edge of Mare Nubium, about a third of the way down the southern hemisphere, and slightly left of center. Now, when 8 days past new, sunrise is occurring along the terminator, and the cliff face stands out in shadow, as seen on the left. The fault is very nearly straight and runs for 110 kilometers, and is estimated to be around 300 meters higher on the east side, 300 meters, with a slope of 2.5 kilometers wide. And to its west is Burt Crater, 17 kilometers wide, and to the northeast of that crater is Rima Burt. It's a slightly curved 50-kilometer long channel, and it could be a former lava tube whose roof collapsed, exposing a half-pipe. Its northern end comes down a mound, suggesting a lava dome, and this in volcanic interpretation. So this particular area on the moon is definitely an interesting one to study for its geological history when the sun is in the right position. On the right, we see the sun setting. This is the terminator as the sun is setting in that region. And at that point, the sun is brilliantly lighting up the cliff face of Rupa Recta. And it makes it look like a sword. There's a curved mountain at the bottom, what's left of a flooded crater that looks like a sword handle guard with the cliff being the sword. There are 2 lunar occultations of magnitude 4 stars this month. The first occurs on Saturday, October 24, with a waxing moon covering Epsilon Capricorni around 9:12 p.m. and 1 week later with a full moon occulting Xi 1 Ceti just after midnight Friday into Saturday. By the way, that star is a double, so you might see it wink out in steps. And now for the rest of our solar system. Here we see a lineup of the 5 superior planets, dwarf planets Pluto and Ceres, and comet 88P Howell on the far right, as of 8 p.m. tomorrow night. Only Mercury and Venus are missing. And Venus will rise around 4:15 the next morning, so if you want to observe these objects as soon as nightfall, you can observe all of the objects seen here as soon as it gets dark. You don't have to wait. And then grab some sleep and come back out at 5 in the morning, and you can catch Venus as it has risen. If you want to also include Mercury, you're going to have to wait until November. There's a great chance to see Mercury in the morning on November the 10th. I'll talk about that in a couple of slides. You might also see some meteors across the sky. That's because we have 4 showers concurrently running at this time. And so let's start our tour as we would when observing by starting with the targets that'll set first and work our way west to east. So we'll start now with 88P Howell. This comet was photographed. Here we see an image taken 1 month ago by Jose Chambo Brice in Spain. And this is the comet's position as of Friday night, west of the Teapot Spout. It was estimated to be at magnitude 9 early in October. The comet passed perihelion on September 2 and is fading now as Earth's orbit is pulling us away from the comet. It should be possible to see it in a small telescope, maybe 8 inches or so, because it's going to be fairly low in the sky, and we're going to need some really good seeing to catch it. So maybe an 8-inch might be adequate to see this comet. And it's running across the top of the Teapot Spout right now, and it'll go through the dome of the teapot and then clip the handle in the first week of November. The comet's 5.5-year elliptical orbit brings it as close to the Sun as Mars and as far away as Jupiter, and its orbit aligns very closely with the ecliptic. The comet was discovered in 1981 by Helen Howell while studying photographic plates for supernovae. Those plates were produced with the Palomar Observatory's 46-centimeter Schmidt telescope, which is now retired. Next up is Jupiter. Jupiter is saying its goodbye after having hung out with us all summer, but it's still quite bright at negative 2.25 tonight and 39 arcseconds wide, but it will be dimming a bit by November 10 and shrinking to 36 arcseconds. But you can easily spot this planet, of course, it's so bright, drifting in the eastern side of Sagittarius, inching ever closer to Saturn. By November 10, the 2 planets will appear 4¼ degrees apart. Colored filters for planetary observing can really help enhance certain features. For example, a blue filter on Jupiter will darken the orangish equatorial belts and the great red spot, it'll make them darker and easier to spot. And if you like to watch Jupiter's moons, here's a fun one for you. At 8:30 on the evening of Sunday, November 1, you can watch Io exit from Jupiter's shadow while Ganymede's shadow is transiting Jupiter. And keep an eye on that little circle. There's Io popping back out. And you can look up Jupiter moon events in the Observer's Handbook or at the websites shown here. Moving east, Pluto is the next solar system object. Under ideal conditions, a 10-inch telescope should be able to see down to magnitude 14.7, making it possible to glimpse Pluto. The image here from Starry Night Pro has the field flipped right to left to match the view in an SCT with a star diagonal, with stars down to magnitude 14.6, slightly dimmer than Pluto at 14.4. So good luck if you want to try. On to Saturn. Saturn is also east of the teapot, drifting slightly eastward over the next 4 weeks. The rings are tilted near their max, showing us their northern face, and they double the overall angular size of the target they are twice as wide. They will double the overall effect of looking at Saturn. Instead of the 17 arc seconds shown in the chart, the overall effect is larger. And Titan is usually easy to spot. If you have a large telescope, you might also pick out some of Saturn's other moons, the faint dots you see here near the planet: Rhea, Dione, Enceladus, and Tethys, and Iapetus just outside Titan's orbit. The cloud bands on Saturn are subtle. A yellow filter can help darken them a bit and make them somewhat easier to see. The dwarf planet and asteroid Ceres passed opposition 6 weeks ago. Its apparent magnitude sits at 7.56, so any size binoculars or telescope can spot it. Here's an 8 arc-minute wide inverted view centered on Ceres. It's in a star-poor area with only 3 brighter than magnitude 14 visible around Ceres. In other words, Ceres will be the brightest dot in that area, making it easy to identify. From Ceres, it's a jump of 23 1/3 degrees northeast to arrive at Neptune. Use Phi Aquarii to easily find Neptune. In a Rigel finder, put the star partway inside the 2-degree circle, around the 230 position, and Neptune should be in your eyepiece. And here's what the view looks through a Telrad site. And here's a close-up, inverted, inside an 8 arc-minute wide field of view. Neptune is the blue circle in the center with Triton, the small dot, beside it. And to the upper left is an 8.7 magnitude star. Now, Neptune can be seen in binoculars or telescope and is easy to recognize by its blue color. But you'll need a 12-inch telescope to spot its moon, Triton, that orbits Neptune backwards, east to west. In fact, Triton's orbit is degrading and it's expected to get so close to Neptune in about 100 million years that Neptune's gravity will rip it apart into a ring. And now we come to Mars, which reached opposition at 7:18 last night and is probably as good as it gets for observing for us here in southern Ontario right now. Now, Mars was closer in August of 2003 when its angular size was 25 arc seconds compared to 23 arc seconds at closest approach a week ago. But back in August 2003, Mars was only 30 degrees high at its highest, which means we were looking through 2 atmospheres to try and study its details. This time, however, Mars is much higher. It's 51 degrees up, so that we're only looking through 1.3 air masses. So we're now looking through quite as much murk. We should probably get steadier air and greater opportunities to observe its detail. So what we lose, those 2 arc seconds in angular size compared to 2003, in my estimation, we more than make up for it with Mars 21 degrees higher in the sky. Notice how rapidly Mars drops in magnitude and angular size by November the 10th. So don't delay. As we pass Mars in our smaller orbit, Mars is continuing in its retrograde motion. As for the details we can hope to see on the surface of Mars, if you haven't already, please have a look at Chris Vaughn's presentation last month, in which he highlights the major Martian features. With Mars so close right now, it should be possible with a 10-inch or larger telescope to spot the tiny moons of Mars, Phobos, 22.2 kilometers wide, and Deimos, 12.6 kilometers. They orbit Mars rapidly. Deimos takes 30.35 hours to circle Mars, and Phobos only needs 7.66 hours. So they do travel around Mars significantly over the course of one evening. This chart, showing the positions of the two moons over time, was generated by Martian Moon Tracker using time parameters that I input. Now, the trick to seeing Phobos and Deimos is to catch them when furthest from the glare of Mars. Over the next 5 days that are shown in this chart, there appears to be a good opportunity around 8 p.m. Eastern Daylight Time this coming Saturday, when those two moons will be as far from the planet as they can get. An orange filter will bring out the dark landforms, and a blue filter will help bring out the polar cap and white or blue limb haze on Mars. And if you're up before dawn, you can catch Venus as it continues its plunge down behind the sun. At 6 o'clock tomorrow morning, Venus will be 18 degrees high with astronomical dawn just beginning. Venus will be gibbous, 76% illuminated, and still brilliant at -4 magnitude. But seeing its phase in a telescope can be a challenge due to the planet's glare. As the sky brightens, however, the contrast between Venus and the sky lessens, and that cuts the glare, making the phase easier to see. And you can also try a neutral density filter or a moon filter to cut the glare. Our best chance to see elusive Mercury is before dawn in the east on November 10. And that's the date of Mercury's greatest western elongation from the sun, when it rises as far in advance of the sun as possible. And with the ecliptic fairly steep in fall mornings, this helps Mercury climb high ahead of the sun. At 6 a.m. on November 10, Mercury is already 7 degrees up, as shown here, and it will reach 11 degrees by 6:30 with the sun still 6 degrees down. This should give you a good opportunity to hopefully catch a glimpse of Mercury's half-lit phase. But give it up after 6:45 or so, as the sun is getting dangerously close to rising. And there are 4 meteor showers currently happening, working our way clockwise in this diagram, starting with the Andromedids. The parent body for that shower no longer exists. It broke up in the 1840s. And the zenith hourly rate for that meteor shower has dropped to only about 3 over the last century, but there is expectation of a future increase as Earth approaches one of the 2 patches of debris left over from the breakup. The northern and southern torids overlap in their timings, which is not surprising since they have a common ancestry. The southern component's parent is Comet 2P Encke. The northern torid's parent is asteroid 2004 TG10, which is believed to be a fragment from Comet Encke. Both have a ZHR of 5, we'll call it 10 together. And saving the best for last, the Oranids are currently showering and are expected to peak a week from tonight with a ZHR of 20. And with a number of showers running concurrently, you do stand a good chance of seeing one if you lie back and look up for a period of time. These showers sometimes produce fireballs. There were 2 fireballs reported to the IMO just last week, one over South America and one over France. The IMO is the International Meteor Organization, and they encourage public reports on fireballs as well as submissions on meteor shower observations. So it's an easy and a fun way to engage in citizen science without having to make a huge investment in expensive gear. You can visit their website to learn more, join, and contribute. And now it's time for Halloween in space.
And it's a graveyard.
And what could be better for Halloween than a full moon? This Halloween features a full moon on a Saturday night with kids running around in costumes high as kites on sugar. And then there are the adults. Scary stuff. But contrary to popular belief, you can observe the full moon. Just use a moon filter to cut the brightness down. Most moon filters reduce transmission by 87%, and that makes it much easier to observe the moon and study its details. You can do geology, looking for the darker areas containing iron, titanium, and other dark metals that tend to sink towards the center of a forming body. So seeing them on the surface would help explain their volcanic journey as they rose up as lava through cracks from huge asteroid hits. The brighter highlands to the south are rich in anorthosite rocks containing aluminum, and you can find volcanic ash deposits during full moon, such as the 3 dark patches found on the floor of Alphonse's crater. Since the sun is overhead there are no shadows, so the dark areas you can see are ash deposits, not shadows. And it's easy to trace the bright rays of ejected material from Tycho. In fact, if you study the moon, you can find other craters with bright rays. Those bright rays indicate that the craters are fairly fresh because over time, cosmic rays, space weathering, and micrometeor hits will remove those rays. Are you old enough to remember E.T. sneaking out on Halloween in a plot to call home? Well, as you may know, he's found a home in space. We call it NGC 457. That cluster is found just 2 degrees southeast of Rukba, or Delta Cassiopeiae. It's a rich cluster with over 150 stars, with noticeable concentration, a large range of brightness, and the cluster is around 7,900 light years from us, and it's quite young at only 21 million years old. And our final Halloween target is the Witch Nebula, IC 2118, a reflection nebula in the constellation Eridanus, west of Orion. The dust grains of the cloud are illuminated by nearby brilliant Rigel. Rigel shines 120,000 times brighter than our sun, which is how it's able to illuminate this cloud lying 40 astronomical units away from it. Now that's 40 times the Earth-Sun distance, or the radius of Pluto's orbit. Conditions in the nebula are favorable for star formation. Astronomers have detected candidates for pre-main sequence stars. They are found well within the Witch's Head, so there are stars forming inside the Witch Head Nebula. The location of the Witch Head Nebula is easy to find. It's a little over 2.5 degrees west-northwest of Rigel, and it's a large object. It really measures more than 4 degrees in length, and that stretches its magnitude of 8 down to a surface brightness of 17.82, and that is faint. To visually see it, you need the darkest location you can get to, no moon, and above average transparency. Now, 4 or 5 inch refractors are capable of showing it, according to a discussion I read on the Cloudy Nights forum. One fellow said he saw it in a 101 millimeter Teleview refractor and a 35 millimeter Panopic eyepiece, and that would provide 15 times magnification and a 4.4 field of view. The bigger your telescope aperture, the better your chances, of course, though they will provide you with a smaller field of view, so you may need to sweep along the nebula's length to see all of it. And that wraps it up. Thank you and have a happy Halloween.
All right. Thank you so much, Arnold. That was a very comprehensive and thorough presentation on the sky this month. Let's move on to some questions. Anya, do we have any?
Well, I do have a question right off the bat. For the Orionoids meteor shower, is it possible to see any within the city, or is it really mandatory to get out of the city to see any?
It's good, mandatory. You know, generally speaking, it's a good idea to get out of the city to see meteors. Many of them may be very faint, and you would not be able to see it with any kind of sky glow. So you really want a dark sky. You really want to pick a night with no moon. If you have an opportunity to get out of the city, that might help. But if you can't, you can always cross your finger for a fireball. Fireballs are so bright they can light up the sky as bright as daytime. So that would be maybe your best chance, as if there is, maybe not necessarily a fireball, but there might be a few that are brighter than average. You might catch one or two that are really bright. But basically, if you can, do try and get out of town.
We have another question that's come in. What capable binoculars are recommended to view Jupiter and Saturn for this year? And also of Mars, of course.
It's commonly suggested that 10 by 50 binoculars are what you would want for astronomy purposes. Now, if you happen to have a different size pair of binoculars in your closet, go ahead and use it. They will definitely show you a lot more than you can with your eyes alone. But if you are in the market for binoculars, you might want to get a pair that are 10 by 50 or 7 by 50. The second number 50 is the size of the lenses up front, and that's 2 inches. And that brings in a lot of light. They're not too heavy at that size either. More popular lately are Poro prism binoculars. They are smaller and lighter weight. You can get them in similar dimensions, like 7 by 48, numbers like that.
Okay, so sounds like we don't have any other questions. We'll move on to our next speaker. Thanks again, Arnold, for your presentation. Much appreciated.
Take care.